Today I wrote a quick blog post called Supercharging LLM Classifications with Logprobs. I recently picked up a book, this one right here by Jay Alamar and Martin Gordendorst. Really good book if you want to understand kind of the internals of large language models and some nice tips and tricks, things that you can do with them. Really an excellent book. I encourage you to pick it up. But one of the real simple little ideas in the book, my mind got carried away, and I decided to expound upon the idea and create something just a little different. The idea is pretty simple. Basically, as you can probably know, you can take a large language model and use it to build classifiers. A sentiment classifier is pretty easy. You just say, take a look at this text, figure out if it's positive or negative, and then just tell me, just spit out the word positive or negative. But there's a problem with that in that it's a hard classifier. It will say one or the other without any kind of nuance. And sometimes it's helpful to know how positive the model thought it was. This is how a lot of traditional ML classifiers work. Basically, you say, give me an estimate of how positive it is, and I'll decide the cutoff. It's not just, it's greater than 50% positive, we'll call it positive. Maybe I know the data, and it's actually, if it's greater than 65% positive, maybe that's a better cutoff line. You can do this with large language models. So let's take a look at it. Obligatory fun picture. First off, let's create a quick hard classifier. Simple idea. I have a Python function that's get sentiment. Take the text in the model. You do exactly what I said. Just tell me, is this positive or negative? Only spit out those words, and then you spit out those words. So when I say this sucks, then it'll say negative. And when I say it's awesome, it'll say positive. But what happens when I say something ambiguous? This sucks, it's awesome. It says positive. Really? It'd be nice to know what it really thought about that. So what we can do is turn this into a soft classifier. Here's how. First of all, you've got to know what logprobs are. And so that's what this little box right here is. Effectively, we tell ourselves lies. We say that large language models take an input prompt and return text. It's true, but really, it returns one token at a time, which is true, but really, actually, for each generation, each token, it's not just returning the text. The model is actually calculating the probabilities of all of the possible tokens, and so you can use that. And okay, so one more level of lie. The model is not actually calculating the probabilities. That would be computationally too intense. It's calculating the logarithm of the probabilities. Logprobs. No big deal though. Take the exponent, you're back into probability space. So let's take our hard sentiment classifier and make it soft. I'll use the same starting point, same message, same response, same completion request, except that with this OpenAI model, I've turned on logprobs, and I've said grab the first 10 logprobs. What this means is it's going to generate, look here, one token. I'm only generating one token, but for that token, it's also going to show me all the second place, third place, up to 10th place tokens, and it will show me the logprobs associated with those. So I'm going to grab those logprobs out. I'm going to take the exponent, and I'm going to print out, in this case, just the two important logprobs, the one for positive, the probability for positive and negative, and then I'll keep track of how much probability was spent on the other tokens, because it's a non-deterministic model. It'll figure out. It sometimes uses other tokens as well. And the good thing is that whenever I say get sentiment with my really ambiguous string there, even though the outcome is positive, it wasn't overwhelmingly positive. The model, you can see by looking at the token probabilities that the model itself was quite confused. Now, with the hard classifier, you can get towards a soft classifier by running it over and over and over again. But for instance, if I'd run the hard classifier 4 times, then maybe it would say it's 75% positive and 25% negative. It takes a lot of runs before it converges to, nuanced differences like this. So, that's the basic idea, but you can do a lot of things with this. In my example here, I've just used positive or negative sentiment, but in general, as long as you've got more than 2 options, you can use this in a similar classifier. Here is some tips and tricks for making your own soft classifier. If you have to have more than one token, you feel free to do that, but just do make sure that they are entire tokens. For instance, we were lucky that positive and negative were single tokens. If the token had been pos or neg, then we would have had to think about it a little bit more to make sure we're getting the correct probabilities set up with it. If your classification needs more explanation, then you're free to do whatever you want to with normal prompt crafting. Include few shot examples, include plenty of instructions about what your domain means. You can also do things like chain of thought. You can say, this is hard, think about it, let it think for a bit, and you can say, now give me the token of your decision, and then collect the log props from that. What's this next guy? Oh yeah, I've just said that there's either positive or negative in our case, and I've just lumped everything else into other. But sometimes other is important. You can figure out if your model is confused with your own classification attempt. You can see that maybe it needs to have other tokens. You can look at the other highly scoring log probabilities and figure out other tokens that you should include in your classifier. And it's probably a good idea to actually include those to give your classifier more nuance. So that's basically it. There's a lot of cool things that you can do with Logprobs, and as a matter of fact, Albert Ziegler, the co-author on the book that we wrote, was using Logprobs while we were at GitHub for some really neat things. Basically, he was allowing Logprobs to instruct him when he has used enough few-shot examples that the model is no longer picking up new knowledge. So Logprobs basically tell us how confused the model is with the information you're putting into it. Once the model is no longer confused, then the Logprobs kind of tighten up. They're expecting the terms that you're giving them. There's a lot of other things that in principle you could do. The one really important caveat today is that a lot of models are locking down Logprobs. OpenAI, to my knowledge, is the only one the only frontier model that exposes Logprobs. You can expose Logprobs through hosted models, although it probably takes a little bit of work to do so. But a lot of models aren't even allowing you to do this, and it kind of makes sense. It definitely makes sense because Logprobs, that data is really juicy data for distilling a model into a submodel. It makes that a much cheaper thing to do. So it makes sense that they're kind of locking it down. But anyway, you've still got this. You can still make soft classifiers. I hope you enjoyed it.